Hi there, in this video I'm going to show you a multi-agent supervisor architecture for data analysis. First I'll be showing you the architecture and then I'll be showing you on how to implement it with Python LangGraph package. So now let's jump into the screens. Now for the purpose of this video I'm going to take the data analysis process of clustering. So this has got two parts. The first is the clustering itself and then it has got the second part is visualization of all the clustering results. So this architecture has got a supervisor agent and then it has got two sub-agents. One is specializing in clustering and other which is specializing in visualization. So this supervisor agent is going to receive a prompt such as give me clustering and then visualize the results, and it will also receive an indication of where the input data file is located. The supervisor is going to take this prompt and it is going to pass the data file to the clustering agent. It will first determine that for this prompt, the first agent to be called is clustering, and so it is going to make a choice to pass all this information to the clustering agent. Once the clustering agent has finished his work of clustering, it is going to pass back the clustering results back to the supervisor agent. The supervisor agent will then say that, which will determine that, okay, now I need to call the visualization agent because the prompt also indicates that I need to make visualization. So it is going to take this clustering results and then it is going to pass it to the visualization agent, and the visualization agent is then going to pass back the results of all the visualization back to the supervisor agent, and the supervisor agent will then reply back with the clustering results as well as the visualization results. Now let us see on how this can be implemented using the Python LangGraph package. So I'll be jumping now to the Python Jupyter notebook. So first we have to import some LangGraph packages, and then I'm also importing some scikit-learn packages. Scikit-learn packages are very useful for making all this k-means as well as visualization. Now I'll be using the OpenAI model O4 mini, and we also need to create a variable called as model which is based on this function which is from LangGraph called as chat OpenAI. You need to indicate your OpenAI key as well as you need to indicate your model. Now you also need to indicate some other additional parameters such as the check pointer. So this is basically useful if you want to ensure that your agent is remembering all the history or the previous conversation. Now let us also look at the data, briefly look at the data. So here I am reading data which is related to some vehicles, some cars. So this data has got the different brand name of the car. It has got the different technical characteristic of the car as well as it has also got the price of the car. So you notice that this data has got both. It has got some kind of numerical variables. It has also got the non-numerical or the categorical variables. Now let us first see on how this clustering agent looks like. So this clustering agent is going to receive this prompt such as give me clustering based on the length, width and price and make 3 clusters, and it will also receive an indication of where the input file is located. Now this agent is going to pass this prompt to a large language model. In our case it is going to pass it to the ChatGPT or O4 mini model. And this large language model is going to look at this prompt and then it is going to fill 3 variables. First, it is going to identify what are the columns which are requested for clustering. In this case, it is the length, width and price. It is also going to identify another variable called as k, which is the number of clusters. In this case, it is 3. And then it is also going to fill another variable which is the location of the input data file. The agent will receive all these 3 information and then it is going to activate the clustering process. So it is going to read the data in a data frame. It is going to apply some transformation. Now the reason why we are doing this is because for clustering purposes you need to transform all the variables into numerical values. So for numerical variables you need to apply some scalar algorithms, and for non-numerical or the categorical variables you need to apply something called as one-hot encoding. Now once all the data is transformed into a numerical values, you can then perform the k-means, which is a clustering algorithm, and then for visualization purposes you can reduce the k-means output to just 2 columns. And the reason why we are doing this is because we do not want to overburden the visualization expert agent. Visual Expert Agent is just for visualization. It is not for data preparation. So we need to do all the data preparation which is necessary for all the visuals directly in the clustering agent. So here what we are doing is we are reducing the complete data set into just 2 dimensions because it is easy to visualize for humans at least data which is in 2D, and we can do that using a PC or the principal component analysis algorithm, which is going to take all the different columns, just compress all that into just 2 columns so that we can visualize it, and then we are going to save that output in a file, and this output file name is going to be passed back to the supervisor. Now let us see on how this is implemented using a Python code. So here first of all we are defining something called as a tool. So this is not yet the agent, it is just a tool or a function which will be then later on used by the agent. So this function or the tool will receive these 3 parameters, the column, the k, which is the number of clusters to be made, as well as the input data file location. We also need to define a description of what this tool is doing so that the large language model can understand what needs to be done, as well as we also need to define description for all these 3 variables so that once again the large language model can rightly assign the right values to each of these variables. Now here I'm reading all the data into a data frame based on this input data file which is passed over here. I'm also copying all the data frame into a separate data frame called as df_cluster. And we need to first of all identify the numerical columns as well as the categorical columns. And then we are going to do all this pre-processing of applying the standard scaler as well as one hot encoder. So if there are numerical columns, we are going to use the standard scaler. If there are categorical columns, we are going to use this one hot encoder. Now once we have prepared this transformer, we can apply it to the data frame, and this data frame will be then transformed into another variable called as x, which will have all numerical values. So your numerical values will be standard scaled and your categorical columns are going to be converted into one hot encoding, ones and zeros. So the x is a variable which has got everything which is available as numerical values. Now we can apply our k-means algorithm. So we are going to apply it on x, and we are going to say that make clusters based on this variable which is k, which has got this indication on how much clusters have to be made. Once the clustering is done, we can apply this principal component analysis algorithm to reduce the data just to 2 dimensions so that it can be used for all the visualization purposes later. And then I'm assigning the PCA1 and PCA2 into this data frame df cluster. I'm also assigning this column of cluster which has got all the different clusters which have been made using the k-means algorithm. And then I'm going to save this output into this particular file name. And then I'm going to reply back to the supervisor agent that the clustering is done and the results are available in this particular file. In case some error happens, we can always communicate back to the supervisor agent that some error occurred and the clustering could not be calculated. Now let us make the same thing also for visualization agent. So visualization agent will also receive the visualization file, which is basically the results of the clustering output. It is going to pass that to the large language model, which is going to assign the file name to this input data file variable. And then the visualization agent will do the process. It will first do this for clustering process. It is going to make a scatter plot based on PCA1 and PCA2 and is going to use the cluster as the color. And once it is done, it can pass the results back to the supervisor. It will say that my work is done and this is output of visualization is available in this particular file name. Now let us see on how to define this tool. So once again, this is just a tool. It is not an agent. It's a function which the visual agent is later on going to use. So this tool or this function has got this variable which is the input data file name. Once again, we have to define clearly what this tool is about as well as what this variable is about. And as I've said, I'm going to use just this function just for clustering purposes. Of course, you can use this visualization agent for any kind of visualization, but for the purpose of this video, I'm going to restrict it just for clustering purposes. So if the input data file name is clustering, in that case, we need to read the data. We need to make a scatter plot based on the PCA1 and PCA2, which are the two dimensions based on the dimensional reduction, and the color of the cluster or color of the scatter plot dots could be based on the cluster. Now once that is done, we can say that the visualization is done, and if it is not done, we can say that some error has occurred, and we pass back this message to the supervisor agent. Now, till now we have just defined these tools or these functions. We have to now create the agent. So agent is basically a model. It is a tool, and then it has got some description of what is the purpose of the agent. So here we are defining the clustering agent. We are saying that, okay, use the model, which is the O4 mini. We say use the tool, which is the clustering, and then we just have to define some description that you are a clustering expert and use this particular tool. Same thing we are also going to do for the visualization. We are going to say that, okay, use the O4 mini model, use the visualization tool, as well as we are saying that you are a visualization expert. Now we are going to create the supervisor agent. So the supervisor agent is going to be created using this LangGraph function called as create supervisor, and it will have these two sub agents. First is the clustering agent, and the second is the visualization agent. It will also use this O4 mini model, and we also need to define what is the output mode. So this is important, and we are saying that output mode is full history. So what does this mean? So whenever there is this communication happening between different agents, we want all other agents to know about it. So for example, we want our visualization agent to know what is happening between the clustering agent as well as the supervisor agent. So if you want this, you need to define that the output mode equal to full history. You will then define some description that you are a team supervisor, which is managing the clustering expert as well as a visualization expert. And then you can say that for clustering, use the clustering agent. For visualization, use the visualization agent, and then that each agent is going to output a file name, which needs to be passed to the next agent whenever it is called. And then you compile this particular supervisor agent into an app, and you can also visualize this app. You can see that this supervisor agent has got these two sub-agents, the clustering expert as well as a visualization expert, and you see these communication arrows which are happening between the supervisor and the sub-agents. Now one thing you'll notice that there is no communication between the sub-agents. It means that there is no lines between the clustering expert as well as the visualization experts. And this is how actually the supervisor works. Everything which is happening between the supervisor and the sub-agent is always between those two, and it is the supervisor's role to ensure the communication to other agents. So for this reason, you'll never find a line between the sub-agents in this supervisor architecture. Now you can invoke this app over here, and for invoking this app, you need to pass the name of the query, which is the prompt. And then you can also define some additional parameters such as thread ID. So thread ID will ensure that the checkpoints are activated. So just for you to remember, the checkpoint is a variable we created earlier, which enables to store all the history so that the agent doesn't forget what were the previous prompts or the previous history. Now you can pass a query such as give me a clustering based on the length, width and price, make 3 clusters, as well as we give an indication of where the input file is located. We can invoke the app, and you can see that the columns are identified, the length, width and price. We also see that the input data file name variable is also correctly filled up. And you can see the result of clustering. You can see that each and every line has been assigned a cluster. And then you also see that there is also this principal component analysis has been also calculated. And this can then be used by the visualization expert. You can see a scatter plot, which is using the PCA1 and PCA2, and the color is based on this cluster. So you can see the blue cluster, you can see the dark green cluster, as well as you can see the light green cluster. Now here you can see the formation of cluster is very clear. you can see that the dots of similar color are close to each other. It means our clustering process as well as the visualize process has worked quite well. Now we can also loop through all the messages which were passed between the supervisor agent and all the sub agents. So here we are looping between all the messages, and first of all you will see a human message. So human message in fact is the prompt. So here you can see that give me the clustering based on the length, width and price, make 3 clusters, and it will also indicate where is the input file located. You can also see an AI message. So AI message indicates that the supervisor is transferring it to the clustering expert. And here you can see that the transfer to the clustering expert is successful. And then the clustering expert is calling this tool or this function which has correctly identified the columns based on which the clustering needs to be done, the number of clusters as well as the input data file name. Now this is the message from the clustering agent. It will say that the clustering has been calculated and it has stored the results in this output clustering tool.csv. And then the clustering expert will say that, okay, my job is done, and it will transfer back the activity to the supervisor agent. Now, here we can see that the transfer to the supervisor agent has been successful. And now the supervisor agent will now determine that, okay, I still need to activate the visual agent expert because the prompt indicates to make a visual. So here we see that the transfer is done to the visual expert, which along with the file name, which is the output of the clustering tool. Now here we can see that the transfer to the visual expert is successful, and here we see that the visual expert has correctly identified the input data file, which is the output clustering tool. So this file in fact is the output which was given by the clustering tool to the supervisor tool, and supervisor tool has then passed it back to the visual tool or the visual agent. Now here we can see that the visual agent expert has said that, okay, I've created the visual agent for 3 clusters, and you can find the output in this particular output file, and then it is going to transfer back the ball to the supervisor, and then the supervisor says that, okay, the transfer back to the supervisor is complete, and it will give a final message. It will say that, hey, I've completed the clustering and I've stored the results over here, as well as I've also made a visualization. So that was a brief overview of how a supervisor agent with sub agents works for a data analysis use case. I hope you found this video interesting. If yes, please do consider subscribing to the channel. Now all this code I've also implemented on my own platform called datajarvis.ai, so you can also check it out. The link is in the description below. See you soon in another exciting video.